is draw a diagram of two molecules of ammonia and show with labels the intramolecular and intramolecular bonds. So two molecules of ammonia. So ammonia is NH3.
NH4 or NH3,
NH3.
yeah.
Ammonia is NH3. Right. To draw the molecule, you have something like this. Can you see that?
Yes.
So if it's getting attached with another molecule, so it's going to be like this. So you have something like this. Can you see that? So
Yes,
this
that's
will,
NH3, right?
yeah, NH3. This will be partially negative and this will be partially positive. So now the bonds that connect hydrogen and nitrogen together within the molecule, that is the intramolecular bond. So here is our intramolecular bond.
Mm-hmm. Intra is the one connecting hydrogen and nitrogen, right?
Yeah, within the molecule. This is within the molecule. The atoms binding, the first binding atoms together within the molecule. So within the molecules of ammonia, the atoms connecting hydrogen and nitrogen together is an intramolecular bond. So it's a covalent bond. Okay.
Okay.
Now, but between one ammonia and another ammonia, we have the we have the intermolecular bonding because it binds molecules together. Is that clear?
So the one binding nitrogen and hydrogen is inter, right?
Yeah, that's between one molecule of hydrogen of one molecule of ammonia and the other molecule of ammonia. Since you're having two ammonia there, so the bonds connecting the two ammonia together is the intermolecular bonding. So here we are only told to draw the diagram and show the indications of the intramolecular bonding and the intermolecular bonding. So what is connecting the hydrogen and the nitrogen together in the formation of ammonia itself as a molecule is the intramolecular bond. That is, but between one molecule of ammonia and another molecule of ammonia, there is another force of attraction binding them together. So that's called the intermolecular bonding. So the intermolecular bond is that very force of attraction that binds molecules together. So the first molecule of ammonia 1 and the second molecule of ammonia 2 are bonded together by the intermolecular bonds. While within the ammonia itself, you have hydrogen binding themselves together. I mean atoms connecting one another together in the formation of this ammonia is called the intramolecular bond. I guess that's clear.
Yeah.
Okay. Then what type of bonding, inter or intra, are broken when water boils? So water is actually H2O, or it's H2O. So the formula for water is, the structure is this, like this, when you check the Lewis structure, right? So if it is binding with another water molecule, it's going to be like this. I hope you can see.
Mm-hmm.
So this will bind with this. This will be partially negative, this will be partially positive. Do not forget that this kind of intermolecular bonding is a hydrogen bonding because for hydrogen bonding to occur, you must have hydrogen connected to the highly electronegative elements. The highly electronegative atoms are fluorine, oxygen, and nitrogen. These are the three elements that causes what? That causes hydrogen bonding. So when they get connected with hydrogen, so they form hydrogen bonding. Okay?
Connected to fluorine,
Yeah, when
nitrogen, and oxygen.
yeah, exactly. So that gives hydrogen bonding. So, but other ones could give polar covalent, which can form the dipole-dipole force. Dipole-dipole two are forms of covalent bonding under intermolecular bonding. Um, that form
Forms of
dipoles.
covalent bonding.
No, no, no. I'm talking about in intramolecular bonding. You said you have three major types of bonding. We have the hydrogen bonding. We have the dipole-dipole, and then we have the London dispersion. So we said the dipole-dipole is actually the force of attraction that binds polar covalent compounds together. If you remembered when we
Say sorry one
discussed.
more time, please. I'm
So
sorry.
yeah, the I said oh, the dipole-dipole as you call it, right? So it's a force of attraction that binds what it's a weak force of attraction that binds polar covalent compounds together. So it binds polar covalent compounds. So
Okay.
we have polar covalent bonds together. Okay, but note that in the formation of dipole, you should remember that we don't have attraction between um, hydrogen and any of these. We don't have the highly electronegative elements attached to them. So that's one reason why. That's one of the indications of differentiating between hydrogen bonding and dipole. For example, we have HCl. HCl is going to be dipole. H2S will also be dipole. Right? Why? Because HCl is actually a force of attraction that binds, hydrogen, and then uh, it's going to form dipole. That's This is going to be
Okay.
partially negative, this is going to be partially positive, and then this is also going to be partially positive, and this will be partially negative. Now you can see that this is actually different from hydrogen bonding because hydrogen bonding majorly includes fluorine, oxygen, and nitrogen. But in the case of dipole, we have dipole charges, but not including the highly electronegative elements. So like fluorine, oxygen, or nitrogen. For example, you can see here you have chlorine here, you have chlorine here. So here we have sulfur. So this is one of the simple indication of differentiating between hydrogen bonding and dipole force. Then the third one also is the last one there under the intermolecular bonding is the London dispersion. Are we there?
Yeah.
So how do you identify?
Yeah, sorry.
Yeah,
Polar covalent is unequal electronegativity, right?
yeah, exactly.
Okay. And then London.
Mm.
Okay.
So well, note that in polar covalent you don't have attachment of fluorine, oxygen, or nitrogen because they are also going to form different electronegativity charges, so positive and negative. As for cases of water or HF, this HF, for example, this is hydrogen bonding because of the presence of fluorine. Right, H2O is also going to be hydrogen bonding, NH3 will be hydrogen bonding. So they are all going to form dipole, but because of the presence of the highly electronegative atom, they are specifically classified under the hydrogen bonding. But as for the following, we've mentioned any other one that forms a dipole as a result of electronegative atom, that of which fluorine, oxygen, and nitrogen are not inclusive, we classify them under the dipole force. Why the London force is actually the force of attraction that binds non-polar covalent compounds together. Non-polar covalent compounds. Are we there?
So bonding, the force that.
Yeah, the London dispersion is a weak force of attraction, or the weakest force of attraction that binds non-polar covalent compounds together. Is a weak force of intermolecular bonding that binds non-polar covalent compounds together.
Weak force of intermolecular.
Exactly. So because it's a type of intermolecular force, so it's a weak force. Is a weak intermolecular force that binds non-polar covalent compounds together.
Okay, a weak
Yeah,
intermolecular force.
exactly. That binds
A weak intermolecular
intermolecular
force
force that binds
binding non-polar
non-polar covalent compounds.